So the way we typically get rid of our waste here in the United States is that we have flush toilets, right? You flush your toilet and then you go about your business. You don't even think about that. So what happens is the waste material that you flush actually goes down into our sewer pipes, a very extensive network of sewer pipes underground that can travel for miles and miles into a centralized wastewater treatment plant somewhere in the city that actually is expensive to build and even more expensive to operate. This is the system that we have. It's very expensive, but we have that and it works. Now imagine you are in a community somewhere else in the world, or it could be in the United States, where you just don't have the resources for this very expensive system. It might take up to $6 million just to install 1 mile sewers in the United States. So imagine if you just don't have the resources to build that, what would you do? Right, so typically, if you don't have a sewer-based sanitation system, you would have something that's on site, whether it's a septic tank or even worse, a latrine, which is really a hole in the ground to handle human waste. That's the reality in many parts of the world. So we ask ourselves as environmental engineers that what can we do to make this situation better? We decided to bring all our tools together using biotechnology and using membrane science, create this machine called the NEWgenerator, which stands for Nutrients, Energy, and Water Generator. That can basically treat the wastewater on site and provide a very high level of treatment with our membrane bioreactor system. Then we basically have wastewater system in the box that runs entirely on solar energy that could be available to communities that don't have sewers. And they don't have to spend all their money building this massive sewer network. They can just put one of these boxes in their neighborhood, and we can just recycle the wastewater and generate clean water for use for either toilet flushing or other uses like irrigation in the community. So I think this has been a game changer in a lot of places. Commercializing the NEWgenerator would not have been possible without the tech transfer office. In many ways, what we've been doing has been very non-conventional because the universities generally don't file a lot of foreign patents unless there's a strong, compelling business case, looking forward. So the USF Tech Transfer Office has been amazing.
The steps we take in any technology that is disclosed to our office are pretty much the same. So we will take a look at whether the technology can be protected by some form of intellectual property, whether that be patent, trademark, or copyright. And then we're also looking at assessing the commercialization potential of the technology, whether it's solving a problem that industry is looking to solve, if it can be scaled up, if it has some advantages over technology that is already out there. So it may be better, faster, cheaper, or stronger. And those are the kinds of things we'll consider. It was a pleasure for the Technology Transfer Office to work with Dr. Ye and to promote his technology. We enjoy seeing how something that comes out of the university can actually benefit society.
So reflecting back and looking forward, I'm glad the NEWgenerator has played a small part in making the world better. This topic of global sanitation, or lack thereof, is massive. And we're glad that we've been able to develop the NEWgenerator as something that people can use in their communities and, basically be able to manage their waste safely and provide clean water and make their lives better.